Hello everyone, this is Ython. I'm going to be going over USACO's February 2025 problem Mexes specifically because I personally like the solution to it. It was very conceptual pretty much. Yeah, so this is making Mexes. I'm going to be going over my solution. I don't know every solution, but I'll be going over what I did and what got me 100%. Um, First, I'm going to describe the problem in case you forgot. You're given n numbers and which would be the amount of numbers in the next line. So like this, right? The input they gave us was four numbers. It was 42220, and it asked you the output should have been n plus 1, the index representing how many actions it took to get that number mex. So it would be, this wouldn't be the output, but it would basically be me saying this. For 0 to be the mex, how many numbers would you have to change? The answer was 1. For 1 to be the mex, how many answers would you have to change? Numbers would you have to change? 0, 2, 3, or 3 changes. 3 would be 1. And then the last one, because it's n plus 1, so 4 plus 1, which is 5. You should have 5 different lines. And 4, I believe, was 2. So that should have been the answer. Okay. And so this is the input, and this is the output you should have gotten. Let me just clarify over here. Input. Output. Right. Okay. Now, first of all, let's explain how do you get these answers. What is a mex? How do you make it, right? The way this they had a short description of what a mex was, and that was, I don't know exactly, but essentially it was the minimum number in the array that is non-negative and not in the array, right? This out here. This is what mex was, right? So I'll give some examples. You're given 1, 2, and 3. The mex would be 0, right? What is the minimum between from 0 to infinity? What's the minimum in the array 1, 2, 3? What's smaller than all of them? That's not in the array, and that is not negative. 0, right? So a different example. 0, 2, 3. The answer would be 1. Mex would be 1. Without changing anything, right? So again, 0 to infinity. What's the minimum of 0, 2, and 3? The minimum would be 0. However, that's already in the array, right? So then that would push up the number 1. Now it's currently 1. 1's not an array. It's a positive. So that would be the mex. So if we look at the input that they gave us, 42220. Sorry. Can I roll this? Yeah. 42220. Here, similar to the second example I gave, the mex would be 1, right? 0 to infinity, it would be 0. Pushed up 1 because there already is a 0. 1 is not there. It's also a positive number. Therefore, 1 is a mex. So now that we've identified what a mex is, how do we get this? Where did the output come from, right? No. Your actual output didn't look like this. It was similar. It was 1, 0, 3, 1, 2. That's what you should have gotten. I just pretty much put a little detail in, right? So for each number like this, the first line is how many, this is exactly what it means. How many actions did it take to get the to get the mex to be 0? And then line 2, which shows 1, is how many actions it take to get the mex to be 1. Like we just went over, for the mex to be 1, you don't need to change anything, right? That's already the mex. But what you need to know is what's considered an action, right? They had a short description, but again, we don't have the actual problem, so I'm just gonna be going over it. So what is an action? Sorry. What is an action in the problem? The action would be to change any one number to any possible number. Now, what do I mean by possible? Possible is, I believe, yeah. Possible. Yeah, no. Sorry, just any possible number, which is obviously in the range. And in the range. So you can't do a negative, no decimals, right? Because why would you? I don't know if they actually had a restriction, but obviously you wouldn't want to do that, right? So that would be one action. Two actions would be changing two numbers, three numbers, and that also means you can change one number multiple times, but yeah, you never need to do that, so ignore that. All right, so now let's go over, now we went over how to get 1, right? How do we get 0 though, right? So we're given again 2220. I'm going to move this over here. Let's go down here. 42220. Like that. Right? Now how do we get 0 to be the max? Because we need 0 all the way to 4, so there's going to be a way to make 0 the max. Right now, there's already a 0. And we know that max it needs to not be in the array already. So first of all, we know we need to change this, right? So how are we going to change that? And what are we going to change it to? You could technically change it to any number and make the max 0. But what we're trying to find is the minimum amount of actions. And the minimum number of actions is 1. Because all you would do is convert this 2220 into 2221, right? That means the minimum between 2, 1, or 0 to infinity, with 2 and 1 being in the subarray, would be 0. If you said 2223 or 222, 224, any other number besides 1, you already would not have gone the minimum, because now, let's say 2223, right? What's the minimum here? The minimum would be 0. 2222, 0 again, right? 2221 would be, oh, sorry. So yeah, you could actually choose any number here. Sorry, mistake. You choose any number here because the minimum is 0 and 1 is greater than 0, so the minimum is 0. Sorry, completely sorry. All right, let's go to number for the max being 2, because we did 0 and 1. So now let's go to 2. So here we see a little bit of a different, or more changes, right? If you want 2 to be the max, you already see like 2 problems. First of all, the max currently is 1. Second of all, there's 3 2s. Yeah, those are 2 problems so far. Okay. So first priority is let's remove all the 2s. And so we can just leave it as x, 0, right? We need to change the 2s to something. Of course, since we wanted the max to be 2, we want every number below 2 to be filled out. So 1, 1, 1. Why not? Boom, that's the answer. we changed 3 2's, so the answer is 3. But note that it didn't all have to be 1. This could have been 100, 100, and 1. And the max would still be 2, right? As long as you had 1 filled out here, as long as you changed some number other than 0 to 1, you would have got the right answer. So that's 1. Now number 3. 3, all you have to do is, again, change one number to the number 1. So 2, 2, 1, 0, right? And obviously don't touch 0, because if you touch 0 and change it to something else, now we're missing a 0. But if you change one of the 2's to a 1, since we already have 2 other 2's to pretty much hold its place, we don't have to worry about, filling out another 2. So here would be the max would be 3. Again, 4. This time the answer would be 2. Again, we have a 0. We don't have a 1. We don't have a 3. We have a 2. So we need to get 1 and 3 and keep 0 and 2. Because we have 3 2's, one of them can stay. We don't need to touch the 0. So with the 2 other 2's, change it into 1 and 3 so that it becomes 3, 2, 1, 0. Which means we changed 2 things. 1, 2, and another 2. So the answer was 2. Okay. Boom. That was the whole problem. Took me a long time to explain, but I explained it step by step. So let's go over the solution now. So here, you guys take a look at this if you need some time to re-understand. Okay. So now let's go over the solution. Okay. I'm gonna pseudocode this in Java. I write in Java, so yeah. But I'll pseudocode it. First, we want to read the line. So, or read the system in. So, read system. Let me read system. So we get n is equal to f next int something like this, right? I'll write in like half actual and half pseudocode. N equals f dot next int, and then for I in n, we would put first. Actually, I'll explain this first, right? So I'm actually gonna have an array of the index representing the number and the actual value of the index representing the quantity. So int, let's just call it array, right? Or ARR. New int. And the length, since in the description, I don't remember exactly, but it said that the numbers that were given were no more than, I think it was like 200,000. I don't know. I'm just gonna put like 100, right? I don't want to complicate it, but what I put it here originally was like some really big number, something like that. Okay, so for I and n, I'm gonna do this. I'm gonna count. The index would represent the count. So, sorry, let me just pull up my reference sheet. Okay. So, for as you go through n, or all the lines, I created a temp value, and that temp, I would open the number. So here in this first iteration, we would get, sorry, let me bring down. So here's our input. In the first iteration of I or n, we would get 2 being temp. And again, like I said, we want to include the index of the array is the quantity of that number, or the index of the array is a number and its value is a quantity. So array, so at index 2, we're going to add a value, right? So here's what the array would look like at this point. At first iteration, it would be 0, 0, 1, 0, 0, so all the way to however big the number was, right? But yeah, actually, I'm just going to close it here, right? After it's run through the whole number, in this test case, 2220, it would be like this: 1, 0, 3, 0, 0, 0, 0, 0, right? So at index 0, the number 0, how many numbers does it have, right? In 2220, there's only 1 0. So at index 0, there's going to be the number 1. How many number 1s do we have? 0. So index 1, there's going to be 0. And then index 2, index 2, how many 2s do we have? 3. So the value is going to be 3. And all the way up to however big the number was would be 0. Okay. Now with that, we've set up all the data pretty much, but what's the actual algorithm? It's actually very short. I think mine here is 4 lines. It's 4 lines. So, I mean, this problem wasn't too complicated, but I really liked how you solved it. So, here's how I'll go over it. So, start of algo. Right. So here, first of all, you're gonna create a variable. And I'll write the code down and then I'll explain it, because you won't get it if you start chronologically, because the variable you use is, incremented. So int fill. Actually, probably not. Or that's like hard to write in pseudocode. This out, or this is just print. I'll just try and print because it's more English sense. Right? It's gonna be hard right now. This. Plus. That's the whole code. Yep, that's it. Then you close off everything. If you did this for 4 or 5 lines and this 5 lines up here, you would have gotten a 100% on making Mexes. Isn't that crazy? One of the hardest coding competitions in USA, and it's 5 lines long is the hardest part. Okay, now I'm actually going to explain it. It's going to be hard to explain, so I'm going to try my best here. So first of all, what is fill? Fill is basically the amount of numbers you have to fill, right? So let's look at the let's look at let's look at the input. It's pretty small, but when we reach the number 2, in order to get the mex to be, okay, let's say we want the mex to be 3, right? There's only one number we need to fill, right? That's 1. So we should keep track of that. That's pretty much all it is. We're just keeping track of how many numbers are not already or are absent from the mex. Which is why down here we increment the value of fill when the value is 0, when there is none. So like this, AR of I, when we reach I to be 1, we see that, there's no number 1s, right? Which is, this double equal, by the way, means the value is equal to 0. So if it's equal to 0, it's not there, we would add to fill. So now we need to fill 1. Another good way of thinking about this, which will also help this max line over here, is once you reach the number to be 0, once you get an answer to be 0, it will never be 0. Ever. And that's because that's because you'll always have to fill that spot now, right? This can go on all the way to 5 million. You can get a different test case, but the moment you see a 0, you're never going to get another answer 0 again, right? Because now you have to fill that spot. Because if you want to make the Mex, you got to fill that one spot, no matter what. No matter how you do it, that has to be, it's going to be a minimum of action 1. So think about it like that, right? Let that sink in. Okay, now what's going on here? This is the last line left, so just hold on a little bit longer. Why are we printing out the max between the numbers we have to fill and the numbers that are actually present? Right? This is easiest to see in this, I guess, in this test case, right? There's 3 2s, and at this point, our fill value is only 1. Which one is bigger? 3. Or the number of 2s, which is 3. The reason why we want to choose a max is because the minimum doesn't qualify for all, it doesn't fit the criteria to make all the changes, right? Although we're finding the minimum of actions to find the mexes, we still need to follow the, the non-negative minimum in the subarray. And if we only had changed 1, there would still be 2 other 2s left, which means it doesn't fill out the spot, right? Yeah, that was not the best explanation, I think. Yeah. I mean, it's about as best as I can say. Yeah, you just print the max between the 2. Let me ponder on how I should teach this a little better. Okay. Here's how I'm gonna do it. So there's 3 2s, right? We need to change these 3. That's basically the minimum in this scenario, right? Those 3 need to get out if we want 2 to be mex. And what Phil is saying is that we also need to fill in 1 spot, or n amount, or not n, sorry, that's f amount of numbers, which in this scenario is 1. So we need to fill 1, but we also need to remove 3. So we need to fit both of those things. And if we only fill 1, we still need to remove 3. But if we remove 3, while we're removing it, because remember, we're not just removing, we're changing it. We're doing an action. And an action is changing any one number to anything. So when we change 3, we also fill in, right? So basically filling and changing is the same thing. So we just want to choose the greater between the 2. Does that make sense? I think that was a much better explanation. Don't know if it's the best. But yeah, so you want to choose a max between the 2. So let's I'll just do a quick little example. So we'll do 0, 5, 7, 7, 7. Okay. And then the array would look like 1, or 0, 1, 2, 3, 4, 5, right? 0, 1, 2, 3, 4, 5, 6, 7, not 5. Ooh, there you go. It would look something like that, right? Pretty sure that's right. Yeah. So here's what the answers would be. It would be 0, 1, 2, 3, 4, 5. Wait. 0, 5, 6. Sorry. Be that. Right. Ugh. How many actions to make the max 0? 1. All we would do is change this 0 for 1, 0, 2, 1, 3, 1, 2, so I think 2, 3, would be 1, 2, 3, 4. Oh, also, I do think there was a, yeah, thinking about it now, I think there's a, they gave you like a certain, so only certain numbers can be in here, because otherwise, like if this was like 0 to 100, it would be impossible. Oh, no. Sorry, ignore me. 5 would be 0, 1, 2, 3, 4. So just 4. That'd be the answer. Okay. Now, you don't actually see the implementation of. Oh no, you do. So, fill here would be going chronologically, like iterating through with the code. At first, it'll be 0. Then it'll be 1, 2, 3, 4. There's 4. And then it's going to say 4 and get a 5. All right. 1, 2, 3, 4. And then say, okay. Sorry. Okay. How do I explain this? Sorry, this is just me pretty much freestyling this video. So, when we want the fill to be 0, when the fill is 0 is when we go over the first line, which is 0. And if we want the max to be 0, all we have to change is that. At this point, fill is 0. And the count of the number that we want is 1, right? We want to change one number is what we're saying with ARI is equal to J. Sorry, printing the max between the two. So which one's greater? The amount we need to change or the amount we need to fill? Which is 1 is 0. So the answer would be 1 equals to 1. I'll just do something like that, right? All right, now let's go to number 2. How many numbers? Oh, I think it's going to solve this wrong. 2 to 1. Okay. And now we go to the next iteration. So what is the max between fill, which at this point is still 0, and this should be 0. Oh, all my stuff is like, oh, it's because I like, oh, something like this. This is the initial, so it kind of, it's hard to write. And yeah, you can't really write this in like text-wise because it's chronologically wrong. Okay, we'll just do something like that. Because you only update the value after you check. So it's at this point it's still 0, even though, because we update the value after we print the max, of course. Okay, anyways. This point fill is still 0. What is the count of 2? 0. Since they're both 0, it doesn't matter. So the max between 0 and 0 is just 0. Okay, so far, the answers are looking right. Now let's go. Oh, also, at this point, I'm going to write it here. Fill plus, right? Again, like I said earlier, once you get an answer 0, you will never, ever get another 0. Because now, that basically is saying the max is 1. in general, from the whole array, the mex will be 1. Okay, so you need to change, you need to fill that spot up, right? Okay, and then number 2. We have 0 number 2s, but we also have a fill, so we need to fill 1, which is 0 to 1, 0 to 3, 1. We need there's 0 2s, we need to fill 1. Okay, now 3. Again, same thing, 0 3s. Oh, also, again, since there were no 2s, if the mex wasn't 1, the mex would be 2. So now we need to fill 1 and 2. Okay. Count of 3. There's no 3s, but the mex is 2 now. So, or the mex has 2 different possibilities. So we need to fill those 2 before we reach 3. Again, fill because 3 was also 0. And then you do this one more time. Now it's 3. Again, we don't have the number, or sorry, we don't have the number 4. So we would add another one. Then here we do have the number 5. Just 1 though, right? And but we still have 1, 2, 3. Our value of fill is still 4. The max between 1 and 4 is 4. So we have to change 4, or we have to fill up 4 numbers, and we have to change 1 5. But when we fill up 4 numbers, we'll also change 5 at the same time. Got it? Yeah, looking back, yeah, the answer, the numbers they would give you, the n numbers, n amount of numbers, its restraint was that the x had to be greater or equal to n, right? So that was a bad input by me. So like when I did 0, what was it, 0 05777 or something like that, since the answer was n plus 1, our answer would never get to 7, because our answer is not supposed to be that long. So this should have been maximum 5, something like that, or something. I'm just gonna keep it like this, just because it would go with this chart. I mean, yeah, not the best explanation, but this is just me freestyling it. The solution still isn't up, so this is pretty much the only way you can check your answers, or at least compare answers. And the contest is over now, so I'm pretty sure I'm allowed to share this. Okay, thank you for watching. If you have any questions, just message me and I can help you. If you didn't get it right, then I can help you code it. All right, thank you, bye.